Okay, similar figures today. That means it's the same exact picture, just smaller or larger, meaning enlarged or shrunk. The picture itself does not change, and that's what similar figures are. Now, throughout this worksheet, I'm using circles and squares to section them off and find corresponding sides. You could use whatever you want. You could use stars and highlight, underline, happy faces. So whatever you want to put next to the number is up to you. Okay, if you're looking at these similar figures, you should know that this is the smallest side compared to this smallest side. So those are corresponding sides. The next, if you look at the Christmas tree, you will realize that these are the same, and that corresponds to that side. So to set up a proportion, you could say, I'm going to do circles over squares, and then I will have 6 on top and 13 on bottom, and the 48 on top and the 104 on bottom. Now that's only one proportion, so I can go ahead and flip that and say squares on top and circles on bottom. So that means I will just have 6 down here, well 13's up here. I will have 48 under by the circles, where the 104 is by the squares, and that's a whole second proportion. Now I can set it up and say, okay, well this time I'm going to compare the small triangle to the large triangle. So I'm going to write small to large, in which case I'm just going to have, so that means I just look at the smaller figure and I compare small to large first. So I will have 13 compared to the 104 on the larger one. And then on the corresponding sides, I would have on the small one a 6, while I had a 48 on the larger one. So it's comparing small figure to the larger figure. Now I could take those and go ahead and do large over small, in which case I just take the original and I flip them. 104, 13, this would be a 48 over 6. Now what you really need to see is these are all the same proportion. If I was to cross multiply, I would cross multiply 6 and 104, 6 and 104, 6 and 104, and 6 and 104. So those are the same proportion, just in a different arrangement. All right, I hope you see the two triangles. The first triangle is your larger triangle, DEA, which is this triangle. Go ahead and redraw it and label anything they gave you. If you notice, this side right here is 16, while this side is 8. So go ahead and label 16 and 8. Now the second triangle, I hope you see it, is right here. It's this smaller triangle within the larger one. So you go ahead and redraw that smaller triangle, and please draw it smaller. Notice this side right here is a 6, and the other side is kind of harder to find, but what you need to know is this whole thing is 16, but you want to subtract this piece off, which is 4. So what you have is 16 minus 4, which gets you this side length of 12. So if you were set up a proportion like the directions say, I get circle, circle, square, square. And you could set up your proportion. I'm going to do circles over squares. So on the larger one, it's an 8 to 16 ratio. And on the smaller one, it's a 6 to 12 ratio. Notice those all simplify to 1/2 because they are proportional to each other. Okay, so on this one, if you drew out your 2, you have the smaller triangle, which has a 9 and a 6. And then you have your larger triangle, which has your 8 down here. But this one is 9 plus the 3, which gets you a total of 12 on this side. So please be sure and circle, circle, square, square. So it's easiest if you just look at it with, hey, look, I can put my lines right here, and I have my proportions. Circle over square is 9 over 6. Circle over square is 12 over 8. And visually, your proportions are right there, 9 over 6, 12 over 8. So, in this case, what I want you to make sure you understand is these. None of them do work, because if you check your cross multiplication, 9 has to be across from 8. And there's a 3 and an 8, there's a 9 and an 8, but look, what's the problem with that? It means we don't use the 3 at all. And then, of course, 9 and 8 and 6 are paired up. So I cannot use the 3. So put a note on here. Do not use the 3 in my proportion, because that 3 had to be added with the 9 for a total of that side length of 12. Okay, number 4, I like these because they have not rotated the picture. So I could put lines between them, and I have my proportion set up right there. I have circle, circle, square, square. So circle over square, 8 over 10. Put your equal sign in between, and it's x over 25. Now there is no scale factor from 10 to 25, but I can simplify this. That's the same as saying, you know what? A smaller rectangle right here would be a 4 by 5, meaning I take these two and divide them by 2. So half of a scale factor will get you 4 over 5. So if I write that 4 over 5 right here, that is an equivalent one. I could use this proportion instead of the 8 to 10 ratio. So then I see, oh, scale factor is 5. Scale factor again times 5. So 4 times 5, x equals 20. And if you go up here, 20 is a reasonable answer. This side is a little smaller than this side, just like this side is a little bit smaller than that side. Now on 5, it's a little different. They've taken this and they have moved it from here, and they've pointed down and then enlarged it a little bit. So they've taken it and pointed it down. So you do have to find the corresponding sides. My missing side is this flat side, not the slant. I see this slant is part of my arrow, and this is the flat side. So the flat side on this smaller figure is the 10. You must correspond them accurately. And then this 5 corresponds to that 4. So again, circle over square. Circle over square. That gets you 10 over 4 equals x over 5. Now there's no scale factor here. I can simplify that, but that only gives me 5 halves. And 2 doesn't go into 5 anyways. So we can go ahead and cross multiply. Now do not forget to write out that one-step equation. That is 4x equals 10 times 5, which is 50. Now this is the part that y'all left off on your test where you're losing so many points, is because you're not showing that one-step equation. All you're doing is going off to the side and solving it. You can after you set up your equation. Divide by 4, divide by 4, x equals. Now I go off to the side and I say, okay, so what is 50 divided by 4? And then I start dividing. A remainder of 1, 0 goes in there 2 times. Your remainder is 2. You may not stop because you have a remainder. 4 into 20 is 5. Then I finally have a remainder of 0. So the final answer, 12.5, which is a reasonable answer if I put it right there. This is going to be longer, at least twice the size of this one to get here. Twice the size, it's got to be larger than 10. So that is a reasonable answer. Okay, if you notice on this, it just has sides labeled, not the side lengths labeled. So this is triangle ABC, and this is triangle MNL, LMN. So that's how they label them. So they want you to still set up a proportion, but we're going to use AB for this side length instead of a number of that side length. So let's go ahead and label. I'm going to label my small side. I'm going to circle, circle. circle, circle. And what I want you to realize is this is a right angle, and that right angle points to the largest side. So this is my square over here. That's my square. So this right angle points to my largest side, and that is my square rectangle over there. So what I get is circle AB over square AC equals LM over MN. Now I could flip those if I want to. I could put AC over AB. And don't forget, there is a third side. So I could use this side right here and do hash marks on that side and say hash marks would be BC, and then I could use one of the other ones, AB equals MN, and then I have to use the same corresponding side. I used AB on the first one, so I have to stick with the blue and do LM on this one. There's a large number of proportions you could come up with this. That's just 2.